Hello everyone, welcome back to one more session of multimedia system. We'll continue our discussion with respect to our topic called the data compression. Let us recall what we had discussed in the previous session. In the previous session we had discussed about various concepts, that is, what do you mean by a compression, what exactly is a data compression, what data is compressed and why it is so important with respect to the data compression, and what kind of data is very important in today's world with respect to compression. And we also studied the importance or the need of compression. We had discussed about the various types, overall the different types of compression. We had just given or discussed a glimpse of the lossy and lossless compression. And we have also seen, can the compression concept corrupt the file? We have seen the many variety of files with respect to a compression. We had discussed, or we had clearly made the differentiation between the data trimming, data deduplication and data compression. So the three difference was also analyzed, and we have seen about the data compression ratio, the space saving and also the advantage and disadvantage of the data compression. Let us look into the continuation. So when we talk about the compression, we need to understand the process, how exactly the compression works. Let us consider during the process of a compression starts with the input data. When we talk about the input data, always it is uncompressed. We should know that always we are taking the data which is uncompressed and we are trying to compress it. So how do we do that? So while doing this process, it involves a process called encoder. So we feed that input data, that is uncompressed data, into the encoder. Why the encoder is so important? It is the phase where the data compression is happening. Means it is the process of compressing the uncompressed data. So when the input is given, encoder compresses the data and provides the output. We get the output data here. So this is not the complete cycle of processing, because we have two things. So one, the data will be compressed and sent. This is one phase, and at the receiving phase it has to be read one, that is inverse of the compression, that is decompression has to be done at the receiving end in order to read the or gain the original data. This is the phase one. So in the second phase, what happens? So before that, we will recall this. Here the compressed data is there, the uncompressed. Here what happened? The data is totally compressed. Input is uncompressed. After encoder process, it is the output what we get is totally compressed. So what we do? This data is fed into decoder. So look at this. Here at the encoder, what kind of process is happening? Data compression is happening. What's happening here with the decoder? Data decompression. And we get the output. Okay. So this is what we call the output at receiver's end. So this whole process can be categorized into two phases. This is the first phase, and from here it is the second phase. What is this first phase called? This first phase is called the transmission part. Means whenever we wanted to transmit the data, we compress it. So uncompressed data is taken and it is fed into the encoder where exactly the compression is happening, and we get the output as a compressed data, and that is transmitted. In the second phase is called the receiving part. So what happens at the receiving part? The compressed data is again fed back into the one more process that is called the decoder process, where the data is decompressed and the original data is obtained at the receiver end. So these are the two phases, that is the transmitting part and the receiving part. So this is the basic thing that one should understand before going into any of the topics with respect to the compression. So why compression is needed, why do we need to decompress, so what is encoder, decoder, so all these terminologies have been explained here. When you know this part very clearly, we can directly involve into the understanding of the different technologies. Now, when we talk about the data compression is broadly classified into two types. So what are those? The first type of compression or a coding technique is called entropy coding. Here the second is called source coding. So overall the concept of data compression is classified into two categories. The first one is the entropy and second one is the source coding. So what is the importance of this? Here the entropy coding is lossless compression, whereas source is lossy compression. What do you mean by this? What do you mean by lossless and lossy? So lossless means during the process of compression, the data is not at all lost. It might be a bit of data or a complete data or to partially or to any extent. So no data is lost during the process of compression and decompression. Whereas in a source type of coding, a lossy compression means a bit of information, a particular portion or a small amount of information is lost. So this is about the source coding. So we study this technique with respect to source and the entropy compression. Now let us go in detail. As discussed, entropy coding is sourceless compression process, while the source coding is totally a lossy compression. The most common multimedia systems use hybrid techniques. When we call it a hybrid techniques, it's a combination of entropy as well as the source. So different techniques of compression techniques of entropy and different techniques of source have been combined in order to form hybrid coding technology. Let us look into the different techniques that come under these categories. The first one will look into the entropy. Entropy coding. What are the things that come under entropy coding? When we talk about entropy coding, the basic technologies or compression techniques that come under this are the run length, arithmetic. These are the different techniques. Okay. Then Huffman coding. So here in this we mainly study about entropy coding in this subject. So in the entropy encoding, we study about the run length, arithmetic and also Huffman coding. And the next is source coding. Under source coding, there are numerous techniques. One is prediction. The first type of technique is prediction. Under prediction, two kinds of techniques are deployed. One is DPCM. So we'll study what are those in detail when we go into the topics. Next is DM. So the first basic algorithm or technique is the prediction. Second one is transformation technique. Even under transformation technique, we have different categories, that is FFT, and the DCT. We have already discussed about the DCT, that is the discrete cosine transformation. And also we have one more thing, that is called layered coding. So when we talk about a layered coding, it constitutes of three parts. One is bit positioning, subsampling, and the third one is subband coding. So this is about the source coding technique, and we have one more thing in addition to these two, that is the hybrid. Here we discuss about the JPEG, MPEG, H.236 and many other factors. So these are the different codings. So as discussed, entropy, the lossless coding. Under the lossless coding, we will be learning about the run length algorithm, arithmetic coding algorithm, and Huffman techniques. And also with respect to source, here it is a lossy kind of coding. So in this technique, we have the first one is prediction. Under prediction, we have DPCM and also DM methods. Under the transformation, we have FFT and DCT. Under the layered types of techniques, that is with respect to coding, we have bit positioning, subsampling and subband coding. And finally, the combination of these two, or the different techniques in combination with respect to source and the run length, is the hybrid coding. So it's a combination of the source and the entropy techniques. So we employ this kind of technique with respect to JPEG, MPEG and also H.236 formats and various other formats. This is the basics of the compression techniques. Next, when we extend our discussion in depth to understand each of the coding, we need to know their properties. So those properties are followed as like these kind of specification. First one, when we talk about entropy coding, it is used with different media regardless of a different medium specification characteristics. Means here in this technique, we don't bother about the different kinds of specific characteristics with respect to mediums. We only characterize with respect to what type of media is given in order to code. This is the first parameter. Second, the data to be compressed are viewed as sequence of digital values. So why I am using this digital value, I will explain this concept, the same value, the importance of digital value when we talk about the run length coding. This is key important with respect to entropy coding. So entropy is totally a lossless compression technique, because the data prior the encoding is identical to the data after decoding. Means the data how it was, what format, the size or the quality of the data that was before the encoding is similar, even the data that is been obtained after decoding is totally identical. That's why we call this as totally a lossless method of compression, and it can be used with different types of data file systems. And the examples I have seen already, the run length, Huffman and arithmetic algorithm. So this can also be used, this entropy encoding can also be used with respect to text, still images, the facsimile, and to some extent of motion pictures and audio coding. This entropy encoding will be very much useful. Next, when you talk about the source coding mainly considers in account the semantics of the information that needs to be encoded, whereas entropy encoding, the semantics was not mainly considered because we don't bother about the different characteristics of a media, but here in the source coding the main consideration is given to the semantics of the information. The second point with respect to source coding is the degree of compression attainable is with respect to lossy technique totally depends on the media. So we say that source encoding is lossy technique. So what is the amount of loss that is obtained with respect to source encoding is, it is directly proportional to the medium that has been used. So this technique is directly associated with the loss with respect to the medium that has been used with respect to the compression. And here there is a relation between the uncoded data and the coded data, whereas there with respect to entropy it is totally identical. There need not to be any kind of relation because it is identical, but here the source and the data before the encoding and the data after decompression, there exists a similarity. We don't call it as both the things are identical, but there exists a lot of similarity. That's why we call this as there is a relation between those two. Why do we call this as there is a relation between those two? Because some amount of information is lost. That is the reason we call this kind of coding as the lossy compression technique, and data streams are similar but not identical. So the data that was before the encoding is totally similar with the data output what we get after the decompression, but we call it as similar, but we are not using the word called identical. Whereas in entropy encoding we used to call these both the things before the data before the encoding and the data after the decoding, that is after compression, are identical. Here we are not calling as identical, but we call it as similar. That is why there is a relationship. The reason is the loss of data. This is about the source. And also we have seen in the previous thing, that is hybrid compression technique. So what we do here in the hybrid compression technique often used on audio and video data multimedia system. That's why, do you remember, recall this, I had written about a JPEG, MPEG and also H.236 techniques. So these are totally motion pictures. That's a combination of audio and video multimedia components. So this hybrid is mainly used in those kind of multimedia systems, and it is the simplest technique that is based on interpolation, where it is possible to make user to feel the different properties. Means we know that the user, whereby user is possible to make the slight difference in any of the media. The best example is the properties of human eyes and ears are able to predict. So this slight difference possibilities identification is the main advantage in order to deploy the hybrid kind of compression technique. So these are the three different major techniques that would be used with respect to the data compression. That is the source, second one is first is entropy, second is the source, and third one is the hybrid. Now let us look into the new concept, that is major steps of data compression. Now we are talking about the major compression steps. Here we are mainly concentrating with respect to image. These things should be made clear, because when we talk about the compression, we are doing a compression to various multimedia elements. So we should be very specific in discussion, and we should be very specific while narrating with respect to what kind of multimedia elements are we talking about. Now here the major steps of data compression with respect to an image is been discussed. Now the very first step in any of the compression methods with respect to the picture or an image is the preparation step. Preparation means what are we doing here? Here picture is pre-prepared. What do you mean by pre-preparation or prepared? So when we talk about this first one, that is a preparation step, it generates an appropriate digital representation of the information, because the image would be not digitized, it would be in the form of hard copy. The first and the preliminary step in any of the compression technique is it has to be digitized. Only the digital components can be compressed. So the first is take up an image, prepare that image into the required format, so the compression techniques can be enforced onto that multimedia element. So prepare the image or generate the image into a digital form that is being used for the compression. So what we do here? Here we divide the image into blocks. Blocks of 8 into 8 pixels. This is the first step. Where what we do here? We take the image and divide into 8 rows into 8 columns. Means the 8 cross 8 pixels with fixed number of pixel bytes per pixel. This is the first step. So what we do in the first step, when the image is ready, it is digitized and divided into blocks of 8 cross 8 pixel with a designated number of bits per pixel. The second step is started. What is the second step? The second step is the processing. And this step is also called as picture processing. Here picture preparation, here it is picture processing. Okay, what we do here in the second stage? Here it is the initial stage, or from this stage the actual use of various compression algorithms are used. Means from this stage the compression algorithms are used. We will see in the later stages what are the different algorithms. We are in general talking, there are n number of compression algorithms. In this stage actually we are using the compression algorithm, because in the previous step the image is digitized and it is ready to undergo with respect to algorithm. So now a compression algorithm is deployed in order for the processing. The one typical example that can be considered here is during the transformation, we always consider the time domain to the frequency domain, that is called the discrete cosine transformation. This kind of transformation is very well suited with respect to the image. And the third process or the step is called quantization. You know very well what do you mean by quantization. That's why in the beginning of the class itself, with respect to the modules, different module beginning sessions, I had discussed the various terminology, that is frequency, sound, compression, quantization, and PCM and other things. So what is quantization? You know that. Now this process of quantization is deployed here. What happens here? Quantization takes place after mathematically the exact picture processing step. Means exact when a picture is done, after the processing of algorithm, the quantization happens. What do you mean by quantization? It is a representation of a total or bigger data into a less space available or a representation form. Means the huge waveform is totally quantized into a smaller waveform. We have discussed this concept with respect to audio technology with respect to module 1, that is 3-bit quantization, 8-bit quantization and 16-bit quantization. The similar way here, the picture is quantized into lesser pixels. The bigger quantity of pixels has been totally reduced into lesser representation with respect to a pixel, we call this as quantization. What kind of quantization? We'll go with when we talk about the exact working principle of the image. And the fourth step is called what we have discussed, that is entropy. So what happens here in this step? It starts with a sequential data stream of individual bits and bytes. So when you talk about entropy encoding, there will be a sequence of bits and bytes of data, we call it as data stream. So when those kind of data streams are there, when it is quantized, we start our entropy concept. So different techniques can be used here to perform the final lossless compression. What are the different techniques? We had discussed at the beginning of this classes that come under the entropy coding. This is how the different steps are used with respect to the data compression with respect to a single image. So when you talk about the picture processing and quantization can be processed iteratively. Why we call it as iteratively means there are n number of pixels that needs to be undergone. So this is called the interleaved activities and is also very much suited in the case of ADPCM, that is adaptive differential pulse code modulation. That pulse code modulation has been already made familiar. These steps, the various steps what we have discussed is always represented with the help of a diagram. So whenever when there is a question that is asked with respect to the various steps of data compression with respect to an image, please do explain with the help of the diagram also. The first, initially we take uncompressed data. The uncompressed data is always fed into the first stage. What is the first phase? The first stage is picture preparation, what we have just discussed. The output of picture preparation is fed into the second level, that is called picture processing. So after the picture processing, the output is fed into the quantization process. Since there is no availability of space, that said, I will be representing the next process here. So what is the next process? That is entropy. I will connect this like this. After entropy is the real data that you get, that is uncompressed. Now let us look into the concept. The first uncompressed data is uncompressed. When we talk about data, what is that? It's a single image. It is fed into the picture preparation process. What happens here in different process stages we have discussed now. After the picture preparation, it is fed into the picture processing. During the picture processing, lot of algorithms that are adequate has been used. So then we do up a quantization process. When the quantization is done, finally we employ the various entropy codings. One of the algorithm like run length, it might be a Huffman or an arithmetic coding. So during that process, the output what we get is totally a compressed data. This is the explanation with respect to the major steps of the data compression. Whenever we talk about the compression, there is one more process that we forget to talk about, the decompression. So decompression is a process that is totally inverse with respect to the process of compression. So specific coders and decoders can be implemented very differently. So at the beginning of the class, I had written a diagram here, that is encoder and decoder. So they can be developed with respect to various vendors in a different form. That's why we have different compression techniques and different formats with respect to compression and decompression. Symmetric coding is a characteristics, or it can also be characterized by comparable cost of encoding and decoding, which is mainly desirable with respect to dialogue applications. When we call about dialogue application, is totally the audio compression. So in audio compression, we mainly concentrate on symmetric coding, whereas asymmetric techniques or asymmetric coding is the process where decoding process is considerably very less costly or very less expensive. So these are the two kinds of decompression techniques that can be used. When you need to have a symmetric with respect to the characteristics, especially when you go with the audio, it is very costly to implement the decompression or a decoder concept. So it is very easy in case of asymmetric, where there is no much kind of synchronization. This is about the thing. Now let us look into the one of the real time coding techniques. So as we have seen, the first method with respect to the entropy coding is said to be a run length coding. Let us discuss and analyze what happens in the run length coding. I make a star here because it is a very important concept that has been asked in many of the final or end term examination question papers. So need to concentrate on this. What is the run length coding? It is the category that lies under the category of entropy coding. When we talk about entropy coding, it is a lossless coding. Okay, there is a difference between lossy and lossless. Here there is no loss or very less coding, loss of data. So here the data often consists of sequence of identical bits, means this kind of coding is very much adaptable, or it can be very much suitable when data bytes are very much identical and it's in a sequential form, means huge sequence of data stream is there and the datas are, the bits of data is very much identical with one another. In this case, this kind of technique is very much suitable. So what we do here, by replacing the repeated byte sequence with a number of occurrences, means when you talk about the data stream with a sequence of identical bits, there is always a possibility of the data getting repeated. So what we do in those cases, we replace those repeated bytes of sequence with number of occurrence, means if a particular letter C has occurred 3 times, we represent the data along with the occurrences. We will demonstrate and see that. Next, a special marker M is needed in the data that does not occur as a part of data stream itself. So when we talk about the repeated or characteristic, we need to have a special marker saying that this is the thing, that character or a data that has been occurred so many times. There needs to be a differentiation between the data and the number, term number with respect to the occurrence. So one should not get confused between the data and the occurrence. So in order to make the difference, a special marker called M is used. But M is not a part of a data itself. This has to be made clear. This M byte can thus be marked as a beginning of the run length coding. Means this letter M marks the beginning of the run length coding, means from here after M the run length coding is exactly been started. A single occurrence of an M can be replaced with the explanatory symbol as interpreted, means here instead of writing M during the process of decompression, in order to avoid the confusion, a single explanatory symbol, you might have seen this, explanatory symbol is interpreted instead of M during the process of decompression. So when decompressed, the exact replica of original data is obtained. This is the beauty of run length coding. So when we talk about run length coding, so the compression is done. When we decompress, the exact identical data that was before data that was there before the compression is same as the data after decompression. So this is the importance of the run length coding. Let us consider this run length coding with respect to an illustration. Now consider, I will write the letter A, and A, and this is a continuous data stream. Here you can look into it, a sequence of characters or bits of information is there. So we call it as continuous data stream. So we have seen that run length coding is very much suited to the data streams, long length data streams with a similar characteristics, or it might be repeated with respect to different sequence of characters. Now let us consider this for example. Now when we push this stream into the process of coding, what kind of coding? We are using run length coding. Now what is the different characters here? Here we have only a single character, that is A. 1, 2, 3, 4, 5. 5 times it has been repeated. So A 5 means A has occurred 5 times. So that's why A is called the data value. So now recall what I said during the explanation of entropy encoding. I said during the entropy encoding we mainly concentrate on data value and also the count of the value. What is the count of the value here? 5. What does this mean? This means the data value is 5 and count of the value means the 5 times that the AAA has been occurred in that data stream. This is the usual convention when we do up. But the run length encoding says we are supposed to use or bifurcate between A and 5. A m byte should be used, means we need to represent A m 5, which means A should be marked 5 times in the sequence. So this is very easy, but there are possibilities of sometimes we getting confused or the process gets getting whether m is a data value or it is a marker value. So in order to avoid this kind of confusion, the m is interpreted, means AM5 is interpreted with the explanatory symbol. So how do we represent now? That is A explanatory 5, means this is same meaning, same meaning, but the representation is different. Now A should be written 5 times, means m is the number of occurrences 5 times. So in the previous understanding it was a marker byte m, now it has been replaced during the process of decompression, that is with respect to explanatory. The meaning of this is implies A should be represented how many times? 5, means 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this is the meaning, means look at this, the original data, that is data stream. So this data stream which is not compressed, I will write here uncompressed. When it is compressed, here it is compressed. When you decompress, you get the original value. Now look at this, the uncompressed value. When you talk about uncompressed value, how many bits are used to represent? 1, 2, 3, 4, 5. Simple. During this run length process of encoding, after compression, when you count 1, 2, 3. So 5 bits of representation is reduced to 3 bit of representation. Obviously, there is a very good level of compression. This is about the run length. Now let us take an example and discuss about the run length encoding in order to have a very clear understanding. Let us take a very big data stream with respect to an example. Now I take the letter B. 1, 2, 3, 4, 5, 6, 7, 8 and a 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I have written the letter B 9 times and I'll write the one more letter A. 1, 2, 3, 4 and 5. So I have written the letter A 5 times. Now I will write the letter N only once because we need to work on all possible parameters. Then I will write the letter G for 2 times. 1 and 2. Let us take one more letter M for 3 times. So this is the input data and this is a data stream. Means a sequence of characters. So it's a big data stream for our consideration with respect to an example. Now we'll count the representation of bits. Now how many times B is represented? B is totally represented in 9 occurrence. How many times A has been occurred? A has occurred for 5 times and letter N only 1 and the G 2 times and the letter M for 3 times. So this is the representation. Now what I do, I apply run length coding technique. So when we say about when we are applying run length coding technique, it is also a representation of M byte which interprets into the usage of explanatory symbol. Now how does run length algorithm work? So here it is totally uncompressed data. We should make this clear, and this is uncompressed data. Now we are compressing this using the run length coding. So how many times B is there? What does the run length says? Data value with the explanatory symbol with the value of occurrences, means number of occurrence of that value. So what is the first data? That is B. M byte is interpreted by explanatory symbol. So next is the number of occurrences of data value. How many times it has been occurred? We know that we have already counted 9. Next, we don't provide any space or something. Immediately we go to the letter A. Explanatory symbol. How many times? 5. Next, what is the letter? N. Explanatory symbol. How many times it has occurred? It has occurred only once. Next, which is the letter? G. Explanatory symbol. How many times it has occurred? 2 times. Which is the next letter? Character? M. Explanatory symbol. How many times it has occurred? 3 times. This is how we are able to compress. Now, how do you say, sir, how did we get the compression? We'll explain this now. Now, when we talk about this uncompressed data, how many bits of information is stored? So here, let us calculate this here. So first is 9 plus 5 plus 1 plus 2 plus 3, which is equivalent to 20. Got it? Now 20 bits of information is used to store the input data which is uncompressed. Now let us look into the how many bits of information is used to store this data after using the run length, that is a compressed data. This is equal to, we will count one by one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. Now look at the difference. Uncompressed data uses 20 bits of information to store this huge data stream. The same data stream is been represented with a compressed form using the run length coding, and it yields with the storage capacity required is only 15 bits of information, which is more efficiently done, means which is less space required. This is called a run length coding. This is how the run length coding occurs. Here, when we encode this or decode the process, means if we represent this compressed into decompression form, there is no loss of data. So whatever data that was there is been obtained. This is called the compressed data. This is uncompressed, this is compressed. If you inverse the process of compression to decompression, you get the original data, which is similar. Look at this. B, how many times? Representation B explanatory 9 means represent B 9 times. 2, 3, 4, 5, 6, 7, 8 and then 9. And represent A 5 times. A 1, 2, 3, 4 and 5. N how many times? Only once. Represent it as 1. G how many times? 2. 1 and the 2. M how many times? 3 times. 1, 2 and 3. So when you look at this one and this one, both are identical. So in the entropy, we call it as the data before encoding and the data what we get after decoding is both identical. This is what the statement I stressed it during that process of saying the entropy. Look at this, both the data is identical. There is no loss of information. This is what we say about the run length coding. So when we want to summarize the session what we have discussed today, we have understood about the different types of compression, that is lossy and the lossless compression, and we have discussed the different types that come under lossy and lossless compression, that is entropy, the source, and the combination of these two is said to be a hybrid. And we have discussed about the major steps involved in the data compression with respect to an image we have discussed, and we have discussed about the decompression also with respect to symmetric and asymmetric technique. And finally, we have discussed about the run length coding with an illustration or with an example also. These are the topics I had wished to explain in this session. Thank you very much.